When creating a trap method, you'll have to input values for each of these variables. If you click on the variables, it will give you a little description of what the variable is and any maximum and minimums. In this video, we will go through each of these variables individually and give any recommendations we have. So if we start at the beginning, our valve oven temperature. The valve oven temperature is a temperature setting for the 8-port valve, sample loop and the trap return line. The recommended starting points for the valve oven temperatures is 0 to 5 degrees above the sample temperature. Transfer line temperature. This is a temperature setting for the heated transfer line. It is recommended to set this temperature the same or 5 degrees above the valve oven temperature. Standard flow rate. This is the amount of gas flow through the system between samples to prevent carryover. To quickly determine this flow rate, divide 1000 ml by the GC cycle time. The result is the starting flow rate that should be used for the standby flow rate. If cross-contamination is observed, it is recommended to first increase the flow rate. If problems persist, investigate high valve and transfer line temperatures. Trap standby temperature. This is the temperature that the trap must achieve prior to sweeping the sample to ensure analytes are retained on the packing material. Be aware of the room temperature as this will affect how low you can realistically set your temperature. For the other variables, they are grouped, so I will skip trap sweep temp and come back to it in just a second. Platen/sample temperature. This is the temperature the sample will be heated to prior to sweeping. Sample preheat. This is the amount of time the sample waits in the platen before sweeping starts. These are grouped as the sample preheat parameters. These parameters control how long and at what temperature you preheat your sample for. Please note that these parameters are only part of the total thermal exposure time for your sample, as if you mix your sample, then it will heat whilst mixing. It is up to the analyst if they heat a sample, mix it, then let it equilibrate, or mix first and then allow it to equilibrate for longer. Preheat mixer. This is the sample mixing prior to sweeping. Select on or off. Preheat mixing level. This value corresponds to the speed that the mixer will turn, levels 1 through 10. Preheat mixing time. This is the amount of time sample is mixed. Preheat mixer stabilize time. The length of time the sample equilibrates after it has finished mixing, but beware the sample is still being heated. These are grouped as the mixer parameters. These parameters are included in your total thermal exposure time for your sample. You can choose the level of agitation your sample requires based on the matrix, with level 1 being the slowest speed. The sample should never be mixed hard enough to allow the sample to be splashed onto the septa. By mixing the sample, it increases the amount of surface area which is exposed to the headspace within the vial and will reduce the time required for the sample to reach equilibrium. Sweep flow rate. This is the rate at which gas sweeps the sample headspace. The optimal settings for this parameter are application dependent. Sweeping too fast can limit the efficiency of the absorbent trap, but sweeping too slowly will increase the time needed to effectively sweep the analytes from the sample matrix. Most applications will have a sweep rate of around 50 to 150 ml per minute. Sweep flow time. This is the time the gas sweeps the sample headspace. The optimal setting for this parameter is application dependent. Sweep flow time should be set so there is enough time to sweep all the analytes from the headspace, so the optimal sweep time can be decided by determining when increasing sweep time no longer increases sensitivity of the target analytes. Typical sweep time is under 10 minutes. These are grouped as the sample sweep parameters. Sweep flow rate and sweep flow time are the two factors which control sample sweep mode. Sample sweep mode is where the gases pass through the headspace vial, which causes the volatiles to be removed from the headspace and deposited on the analytical trap. The trap sweep temperature is important when sweeping, and for many applications you would want it to be at ambient temperature. The trap sweep temperature is the temperature that the trap will be held at during the sweep mode to ensure analytes are retained on the packing material. Dry purge time is the amount of time dry gases pass through the trap to remove excess water. The length of time is dependent on the sample matrixing temperature. Typically, a 1 to 2 minute dry purge is efficient. Dry purge flow is the rate at which dry gas sweeps the trap to remove water. The flow is dependent on the sample matrix and the target analytes. Typical dry purge flows are between 40 to 100 ml. Dry purge temperature. This is the trap temperature set point during dry purge. It is recommended this temperature is set close to ambient. These are grouped as the dry purge parameters. The dry purge is used to remove water from the trap prior to injection onto the GC. To avoid damage to the trap, a dry purge is recommended prior to heating the trap, especially when using a desorb preheat as there is no gas flow. A balance is needed. Too long with high flow could cause a potential loss of very volatile analytes. Too short, followed by a high temp desorb preheat, can mean that there is potentially water still present and this could damage the trap. Desorb preheat. This is the trap temperature set point prior to desorption to free analytes from the packing material. Typical desorb preheat temperature is 5 degrees below the desorb temperature setting. Desorb temp. This is the temperature the trap reaches before the 8-port valve rotates to allow the GC carrier gas to sweep analytes onto the column. Typical desorb temperatures are between 180 to 260 degrees, but is dependent on your trap. Desorb time. This is the amount of time the 8-port valve is rotated, allowing GC carrier gas to sweep through the trap and deposit compounds onto the column. This time is typically between 1 to 5 minutes, but dependent on trap type, target analytes, column internal diameter, and the GC injection port. These are grouped as the desorption parameters. When in desorb mode, the 8-port valve rotates to backflush analytes from the trap to the GC. The temperature should be selected based on the trap being used. To select the desorb time, the internal diameter of the column and the flow rate should be taken into account, but the aim is to allow enough time to fully desorb the compound with the highest boiling point. Trap bake temperature. The trap bake temperature is the temperature set point to bake off any residual compounds. The trap manufacturer will recommend a bake temperature, and if the temperature is set above this recommendation, it could lead to shortening the life of your trap or damaging it. Trap bake time. This is the amount of time the trap is in bake mode. This typically should be set long enough to remove any residual analytes from the trap. Typically this is 1 to 10 minutes. Trap bake flow. This is the gas flow during the bake mode. Sufficient flow is needed to remove any residual analytes from the trap, but not to sweep so fast that it will damage the trap. These are grouped as the bake parameters. This mode is used to bake the trap before the next run to remove any volatiles remaining on the trap and any water in the system. Typically, baking the trap comprises of passing gas through the trap at a high rate with an elevated trap temperature, which is above the desorb temperature but below the limit of your trap. If you wish to know how to create a trap method, please see our other software guides.